Alright, welcome everybody. So today we're going to talk about balancing reactions in acidic and basic conditions, and depending on how much time that takes, maybe we'll talk a little bit about using Table J. But we'll definitely do acidic and basic conditions, so let's talk a little bit about that. So these are the more difficult balancing reactions, the ones that I mentioned in class. So far we've done simple balancing reactions where you just find out how many electrons were either lost or how many electrons were gained. You balance the two half reactions, you make sure that the electrons have the same number lost and gained, and from there then you could either plug it back into the equation or you could write in an Ionic equation. Now in this case we're going to have things that are more complicated. We have a situation where now you're going to have polyatomic ions. All of these reactions always take place in aqueous solutions, and so what that means, whether you think about it fortunately or not, you have to write a net Ionic equation. So the process of writing half reactions is similar. You're going to write two half reactions, but now we have more going on. So let's go through the steps here. The first step is to assign the oxidation numbers and look for any changes. So if I zoom in here on this practice one that I'm going to do with you, the Fe is already assigned, the Mn is +7, the O is -2. On the other side, the Mn is +2 and the Fe is +3. So all the oxidation numbers are assigned. Then I'm going to write half reactions for any simple ions. And in this case, we actually do have a simple ion, Fe +2 to Fe +3. And so now I'm going to write that half reaction. Fe +2 goes to Fe +3. I need to balance this for electrons, so I'm going to add an electron to the more positive side, and now the charges are balanced. The charge got more positive, so this would be an oxidation reaction. Now I have the Mn. The problem, though, is that the Mn is in a polyatomic ion, permanganate, and I can't just take out the Mn +7. There are some cases where you can do that, but in the end, what you'll see is that you'll be missing oxygens and hydrogens, and you'll have to go back and do what I'm about to do anyway. So in this case, I'm going to keep that permanganate together. So we're going to have our MnO4-, and it's going to yield Mn +2. Now there's multiple problems with this, but let's look at them one by one. So first I'm going to look to see if there's any elements other than oxygen that need to be balanced. And I don't have that as a step in here, but that is something that I need to do. And I see that I have one Mn and one Mn, and so they are both balanced. The next thing in step 4 is I'm going to use water to balance the oxygens. I have 4 O's in permanganate, so I'm going to add 4 waters to the other side. So now I've introduced a new element. Now I have hydrogen. This is going to be in acidic conditions, and so because of that, I'm going to have H pluses on the left side. And so when I do that, I'm just going to move this over here. And so when I do that, I have 8 H's from the water, and so now I'm going to add 8 H pluses to the left side. So now I'm almost ready to finish balancing this half reaction. I have the right number of manganese, I have the right number of oxygens, I have the right number of hydrogens. Now I need to balance the charge. I have 8 H positives, and I have 1 negative. That's +7 on the left, and on the right +2. So the left is +7, the right is +2. I need to add 5 electrons to the left side to balance that. Now, if at any point you want to pause the video and try this on your own or go back and carefully see what I did, you should do that. So now I have my two half reactions. I look at the electrons and I see that the manganese has 5 electrons that have been gained, and the iron only lost 1 electron. So now I need to go back and balance the iron side for electrons. And so now I'm going to use 5 Fe's to balance my electrons. And now I'm ready to just add the two together. So now if I add the ones on the left, I have 5 Fe plus 2, 8 H plus MnO4 minus yields 5 Fe plus 3 plus Mn plus 2 plus 4 H2O. The electrons will cross out. And now the fun part. I have to go back and check this. 5 Fe's on the left, 5 Fe's on the right. 8 H's on the left, 8 H's on the right. A manganese on the left, a manganese on the right. 4 oxygens on the left, 4 oxygens on the right. And you think that you're done, right? And you're like, okay, that's great, but now I need to check the charges. On the left, I have 10 plus, and 8 plus is 18. and then a -1 from the manganese gives me plus 17. Seems like a weird number, but let's look at the right side. 5 Fe plus 3s, that's plus 15, plus 2 from manganese plus 2, that's plus 17. The charges balance on each side. So in this case, I had to go through, and this took a lot of work. And like I said, these are only on the SAT subject test, they're not on the Regents. I would say do these questions last. They take a lot of time, and you still get only the 1 point for doing them. Are they rewarding to do? Yes. But they could be frustrating, because if I made a simple mistake, maybe I didn't add the right number of oxygens or hydrogens, I could end up in a situation where I don't do these properly. Okay, let's